Assalamu alaikum students. This is the second lecture about projectile motion. In the previous lecture we discussed about the motion of particles under constant acceleration. That means if acceleration of the body is constant. So we discussed that if acceleration of the body is constant, then the body can have only two types of paths. That's one dimensional motion, that's called a straight path, or the body can have parabolic path, that's also called as two-dimensional motion. So one-dimensional motion is only possible if initial velocity is 0, or if the direction of initial velocity and acceleration is either same, that means angle between them is 0 degree, or opposite, that's angle between them is 180 degree. That's if theta is 0 degree between u and a, or if theta is 180 degree between u and a. U is initial velocity and a is acceleration, then body will move along a straight path. That's one dimensional motion. And in all the other cases, that means any other value for theta, the body will have parabolic path. That means if u is projected at some angle theta, with acceleration, that means if u and acceleration a have some angle theta between them, but this theta should not be equal to 0 degree, this theta should not be equal to 180 degree, then the body will have two-dimensional path, that's called parabolic path. So we have to discuss this thing. So in the previous lecture we discussed these things with some examples also. So today we will be moving further. Okay, today we will discuss about different types of projectiles, or we can say different types of projectile motion. This is actually two-dimensional path, or the body moving in two-dimensional path is called projectile motion. So let me tell you some different types of projectile motion which we are going to discuss in these series of lectures. उसमें से पहला आता है जब हम एक ऑब्जेक्ट को ग्राउंड से प्रोजेक्ट करें with some initial velocity u, make an angle theta with ground. तो जो बॉडी, this is x, this is y, तो बॉडी जो होगी इसकी ट्रेजेक्ट्री, दैट मीन्स पाथ जो ऐसे होगा, ठीक है. तो बॉडी यहाँ से हम इसको थ्रो किया विद इनिशियल वेलोसिटी u एट सम एंगल थीटा, इसकी एक्सेलरेशन, डायरेक्शन ऑफ एक्सेलरेशन इज डाउनवर्ड्स, दैट्स g. So angle between u and g is neither 0 nor 180 degree, so it can have two-dimensional path. This is two-dimensional path. This is also called projectile motion. तो एक तो हमने ये डिस्कस करना है इसमें, एक टाइप ऑफ प्रोजेक्टाइल. सेकेंड टाइप ऑफ प्रोजेक्टाइल जो हमें डिस्कस करना है कि अगर हम किसी बिल्डिंग से, दिस इज सम बिल्डिंग विच इज एट ए हाइट h, यहाँ से हम किसी ऑब्जेक्ट को हॉरिजॉन्टली थ्रो कर रहे हैं विद सम इनिशियल वेलोसिटी u, तो यहाँ पे इस बॉडी का जो पाथ होगा दैट विल बी लाइक दिस. That's also two-dimensional path. So body will be here. This is second type of projectile. Third type of projectile which we are going to discuss is if we throw object from some height h above the ground, but we'll throw it with some angle with horizontal. This is you making an angle theta with horizontal, so the body will be like this, path of the body will be like this. So finally the body will be here at ground. Next one, we will throw the object like this, like this. You make an angle this theta with x-axis horizontal. So here the path will be like this. So object will be here. This is also two-dimensional path. And if we throw a body on an inclined plane, this is horizontal. We have to throw this object. We are throwing it like this. This is U. So here the body will have path like this. This is another type of projectile. And the last type of projectile which we are going to discuss is if we throw an object down the inclined plane with some initial velocity u. So here the path will be like this. So it will be here. Direction of motion, direction of motion. This is the direction of motion. This is the direction of motion. Here this is the direction of motion, and यहाँ पे ये है direction of motion. So these are the different types of projectile motion जो हम अपने इन lectures में डिस्कस कर लेंगे. तो पहला प्रोजेक्टाइल जो हम डिस्कस कर लेंगे दैट्स दिस. So take it as origin. This is x, this is y. Here is an object. We have to throw this with initial velocity u, make an angle theta with x-axis. So the path of this be just like this. अब देख लो initial velocity जो हमने दी यहाँ पे u, initial velocity is u and acceleration is in this direction. A is equal to g. So here A is equal to g. It's always downwards, that's towards center of earth. So we are given u and we know acceleration as well. Angle between them is neither 0 degree nor 180 degree. That means the body will have two-dimensional path. So if we have to calculate the velocity along this path at any point, or we can say that if we have to calculate the velocity of this object after time t at any point, suppose I will tell you here what is the velocity here, so I can find the direction by drawing the tangent along at this point. So we can say this will be the velocity, direction of velocity, but we have to find the magnitude of the velocity. So how can we find this? We know this type of motion, it's a uniformly accelerated motion, so we can say v is equal to u plus at. This is first equation. Second is s is equal to ut plus 1/2 of at square. तो ये टाइप ऑफ मोशन जो है ये यूनिफॉर्मली एक्सेलरेटेड मोशन है. तो हम ये इक्वेशंस यूज़ कर सकते हैं कि अगर मुझे फाइनल वेलोसिटी निकालनी है, और वी कैन से दैट अगर मुझे वेलोसिटी निकालनी है आफ्टर टाइम टी तो मैं ये इक्वेशन यूज़ कर सकता हूँ. मुझे कहीं पे भी आफ्टर टाइम टी मुझे डिस्प्लेसमेंट निकालनी है तो मैं ये इक्वेशन यूज़ कर सकता हूँ. तो ये दो इक्वेशन में यूज़ कर सकता हूँ. तो अगर मैं ये पहली इक्वेशन ले लूँ पहली, तो ये क्या कहती है मुझे, v इज इक्वल u प्लस ए टी, मतलब जो v है ना इट्स द वेक्टर सम ऑफ u एंड ए टी. u इज द वेक्टर, a t is also a vector in the direction of acceleration because t is a scalar, that means a t is a vector in the direction of acceleration. So the direction of u and a t it's not same, it's different, so we cannot add it simply by algebraic sum. We have to Either we can resolve u along components in along x-axis and y-axis, then we can add it. So let me write u. We can resolve u along x-axis and along y-axis. Along x-axis, let it take as ux, denoted by ux, and along y-axis, let it be denoted as uy. So we can write u as ux I cap plus uy j cap, and we know acceleration is downwards. That acceleration is along x-axis, it's 0, because the component of acceleration along x-axis is 0, because it makes an angle of 90 degree with x-axis. That means the component of acceleration along x-axis is a cos 90. Cos 90 is 0, that means acceleration is 0. So we can say that it's minus g j cap, because acceleration is downwards towards negative y-axis, that's minus g j cap. So from here we can calculate v from this formula. That means v is equal to u, that's ux I cap plus uy j cap, it's u, plus a, that's minus g j cap minus g j cap into t. So v is equal to uxi plus, here jj, they are along the same axis, so we can write it as uy minus gt j cap. So this is the velocity after time t. So we can find the velocity at any time on this projectile, or we can say that we can find the velocity of the body after any time t, and this is the equation of velocity. Second thing, if we have to find displacement, that's s. This is the formula for that. S is equal to ut plus 1/2 of at square. So we can write it as s is equal to ut, u means ux I plus uy j, that's ut plus 1/2 of at square. What is a? It's minus g j cap t square. So we can write s as uxt I cap plus uyt j cap plus minus g by 2 t square j cap. Further solving this, s is equal to uxt I cap plus uyt minus g by 2 t square j cap. This is the displacement after time t. Displacement after time t, and this is the x component, or we can say that x coordinate. This is I cap, that means this is along x axis. This is x coordinate, and this is y coordinate. So we can find now the velocity after time t, and we can find the displacement after time t, or we can find the coordinates of an object after time t. This is the method. And second method is like this. We are given initial velocity u as ux I cap plus uy j cap. We are given acceleration as minus g j cap. It's given from here. Initial velocity is given, theta is given, that means ux is given, uy is given, and acceleration is given. So if we are given acceleration, so we can find anything. So we can say acceleration is equal to dv by dt is equal to minus g j cap. So dv is equal to minus g dt j cap. So we can integrate this both sides, this equation. At t equal to 0, initial velocity is u given, and t equal to t, final velocity, which we have to calculate. So it will be integration of dv will be v from limits u to v. It will be minus g, that's constant, this body is moving with constant acceleration, and integration of dt will be t from time 0 to t, and it's j cap. So we can write it as v minus u is equal to minus gt. If we give the limits, that's t, it will be minus gt, then 0, it will be 0, that's minus gt j cap. So v is equal to u minus gt. So giving the value of u, that's the initial velocity, v will be uxi, sorry, it's j cap here, uxi plus uyj minus gtj. So it will be like uxi plus uy minus gt j cap. This is the velocity v. Is same which we have calculated earlier. So after we can find displacement, that's ds divided by dt is equal to v is equal to uxi plus uy minus gt j cap. So ds will be its vector, dt will be on this side, j cap, it will be dt, integrating both sides between the limits at time equal to 0, body is at origin. I have taken this as origin, so body is at origin, and final is s. So it will become s is equal to ux, its initial velocity, that's constant, so the integration will be uxt I cap plus uy, it's also constant with respect, sorry, uy, it's also constant, its initial velocity, so that means it will be uyt minus g is also constant, but t, it will be t square by 2 j cap between limits 0 to t. So if we substitute the value of t here, then minus the value of substitute 0 for t, it will whole become 0, though t minus 0, it will become the same, uxt I cap plus uyt minus g by 2 t square j cap. Then displacement is equal to uxt I cap plus uyt minus 1 by 2 gt square j cap. This is the displacement after time t. It's same like this. So these are the two different ways how we can find displacement or velocity. So this ux is the velocity component of velocity along x-axis after time t, along x-axis after time t, and this is the velocity component after time t along y-axis. So we can say that the initial velocity along x-axis, that's ux, and the velocity after time t along x-axis is also ux. That means it's along x-axis, we can say along x-axis motion is uniform motion. The body is moving with uniform motion, that means with zero acceleration, and we know that ax is 0, a along acceleration along x-axis, that means a body is moving with uniform motion along x-axis, that means with constant velocity, but along y-axis a body is moving with acceleration that's equal to minus g. That's why the velocity after time t is equal to uy minus gt. So this is uniformly accelerated motion. Uniformly accelerated motion along y-axis. So if we have to find velocity after time t, so we know vx will be equal to ux, so we don't need to find the velocity along x-axis. So we only have to find velocity along y-axis, that's the y component of velocity, and that will be equal to uy minus gt. Then we can find v, and the magnitude of v, if we have to find magnitude of v, so magnitude of v will be under root of x component square, that's ux square, plus under root of y component square, that's uy minus gt. Oh, sorry. Ux square minus this square. This is the magnitude of velocity. Same if we have to find magnitude of displacement, so we can say that magnitude of displacement after time t is equal to under root of x coordinate square plus y coordinate square 1 by 2 gt square whole square. This is the magnitude of displacement after time t. We have, okay, let's discuss a question so that we can use these things, it will help us. So the question is like, a particle is projected with velocity of 50 meter per second. Particle is projected with a velocity of 50 meter per second, making an angle of 37 degree with horizontal. If this is the horizontal, it's making an angle of 37 degree with horizontal. Question is, find velocity, displacement, and coordinates of the particle, and x coordinate and y coordinate, x and y coordinate of the particle with respect to starting point after 2 seconds. Okay, this is the starting point. So the body will move, the path of the body will be like this. Suppose after 2 seconds body or the object is here. So what we have to find is this distance, this is the x coordinate, and this distance, this is the y coordinate. Here is x axis, this is y axis, it's x and y coordinate, and we have to find v here. So the direction of v will be like this. We have to find this v. So we know this is u is 50 meter per second. To find v, we should know ux and uy. So ux will be u cos 37 degree, because u makes an angle of 37 degree with horizontal. That means component of u along horizontal will be u cos 37, and uy will be u sin 37. So this angle 37 degree we know. अच्छा सुन लो, अगर कोई नहीं जानता तो यहाँ सीख ले. हमारे पास एक पाइथागोरन ट्रिपलेट है 3 4 5 3 4 5. दैट डजंट मीन कि ये सिर्फ 3 4 5 के लिए वैलिड है. दिस मीन्स 3x 4x एंड 5x. अगर कोई भी ट्रायंगल जिसके साइड्स इन द रेशियो इसके रेशियो में हो 3x 4x एंड 5x, तो obviously this will be 90 degree, and the angle opposite to side 3, it's 37 degree. and another will be 53. So from this, what is the value of cos 37? This is u is 50, cos 37 will be based upon hypotenuse, that's 4x divided by 5x, that's 4 by 5, that is 40 meter per second, that's ux. And same here, this will be 3 by 5, this is 30 meter per second. So we know ux is 40 meter per second and uy is 30 meter per second. So we can find v after time 2 seconds is ux I cap plus, from the formula, ux I cap plus uy minus g t j cap. Substitute the values. Ux is 40 I plus 30 minus, let's take g equal to 10 meter per second square. The value of g is otherwise 9.8, let me take it 10, that's 10 into 2, that's 20 j cap. So the velocity is 40 I cap plus 10 j cap. This will be the velocity after 2 seconds. If we have to find the magnitude of velocity, then it will be under root of 40 square plus 10 square, that is under root of 1600 plus 100, that is 1700 meter per second. Okay, now we have to find displacement after 2 seconds. So for s displacement, we know formula, that's uxt I cap plus, that's x component, or is uy t minus 1 by 2 gt square j cap. So that's ux is 40 into after time 2, that's I cap plus 30 into 2, uy is 30, yes, 30 into 2 minus 1 by 2 10 2 square j cap. Here 1 2 1 2, it's 60 minus 60 minus 20 j cap, this is 80 I cap. This is s, that is displacement. So displacement is 80 I cap plus 40 j cap in meters. Here we can say this is in meter per second. So this is the displacement. So now the x coordinate is, this is I cap means it's along x, it's 80. So the x coordinate is 80 and y coordinate is 40. Okay, if we have to find displacement, magnitude of displacement, it will be 80 square plus 40 square. Calculated, that will be the value of displacement. 80 and 40, it represents this thing, the value of x from here to this point, it's 80 meters and this is 40 meters. 80 and 40, this is the answer of this question. So इससे हमें सारा जो भी हमने पीछे पढ़ा था लास्ट में वो सारा क्लियर हुआ। इंशाल्लाह नेक्स्ट लेक्चर्स में फिर से क्वेश्चंस करेंगे।